Hello friend, in today's video we will learn how we can design and develop a smart irrigation project by using the Raspberry Pi real-time hardware. So you can see on the screen we have the Raspberry Pi, we have the moisture sensor, we have the DHT11, then we have the soil moisture, we have the rain sensor, and also we have the mobile application. Also to start and stop the motor we have the relay board. So how to use these different types of hardware in the one project we will definitely learn by using this video. So I request you please watch this complete video so that you can easily develop and design this project. So before start this project I would like to tell you the idea behind this project. So first you can see whenever we run the project you will see the welcome message on the screen, and after that there will be the smart irrigation message present on the screen, that is the project name. So after that our motor will be waiting for the moisture sensor, humidity sensor, that is DHT11 sensor output, that is humidity, and what is the temperature value output, and based on that it will turn on and turn off the motor. Also real time you can see whatever the status of this motor, whatever the status of the sensor, like the moisture sensor status, humidity sensor status, temperature sensor status, and the motor output also present on the mobile application, so that farmer can easily detect what the current atmosphere condition for his vegetable or for his farming. So first part is the moisture sensor will detect if there is more water or not. So if there is no water, then automatically the motor will turn on, and this motor is actual water pump motor. It is a mini water pump motor, and this start pumping the water. You can see on the demonstration part, you will definitely see what is the real-time output of this project. So after that, if the moisture sensor detect the water, then this motor will be automatically turn off. Also you can see on the screen we have the DHT11 sensor. So what is important of that sensor? So this sensor will basically detect the atmosphere condition. So it detect what is the moisture value and what is the temperature value in the atmosphere. So we have given some threshold in the programming. So if the humidity sensor value and the temperature sensor value comes below this threshold, even the moisture sensor detect the sufficient water, then also the motor will start, because the atmosphere condition is not good for the farming. So this is also second criteria. So motor start will be depend on the two conditions. First condition is the moisture sensor output directly, and the second condition is that humidity value and the temperature value output. Now the third part is, you can see on the screen we have the rain sensor. So what is important of that rain sensor? So let's say in some condition our motor gets started and the rain is detected. Okay, when the rain is detected by the rain sensor, then automatically motor will be stopped even there is no water detected by the moisture sensor, because it is a natural condition. So for that reason we have used the rain sensor. So this is the complete idea behind this project. So I request you please watch this complete video so that you will get idea about hardware connection, how to connect the different types of hardware with Raspberry Pi, what is the programming, and how to design the program, what is the importance of each and every line of this program, you will understand from this video. And also we will see how to design the mobile application for this project. So we will cover all the aspect of this project in this one video. So there is one important information. If you want the simulation part of the same project, you can watch my video, that is simulation part of the smart irrigation project video. The project link is given in the description, and this program and this project is completely free of cost. You do not have to pay any single rupees for this project. Just you have to pay the attention till the complete of this video. So I request you please watch this complete video so that you will get idea about each and everything about this project. Thank you. So first part we will see the final demonstration of this project so that you will get idea about how the project will work, and after that we will see the hardware part, then programming part, and then we will see how to run this project. So please watch this complete video. So as you can see, we have the many sensor in our project. We have the moisture sensor, then we have the DHT11 sensor, then we have the rain sensor, then we have mobile application, also water pump motor. You can see I have connected the water pump motor here, so we can see the importance of this motor later. Then at the controller side we have the Raspberry Pi and LCD. So at the starting when you run the project, then it will show the what is the temperature value and what is the real-time humidity value from the DHT11 sensor on the LCD. And currently you can see the motor off message present on the LCD, and you can see also mobile application, the motor status is off. So why this? Because our humidity value is greater than our threshold, so it is sufficient to turn off the motor. Also the temperature also greater, that is more than 30 degrees Celsius. Also you can see at the moisture size, the moisture sensor I have dip into the water, so that it is stated as there is a lot of water required to the plant, so that this motor is not getting started. So now you can see we can demonstrate the first part of our project. So first part is that whenever I plug out this moisture sensor from this water, then you can see here motor on message will be present on the LCD. Also on the mobile application, motor on message, that is this red signal turns into green signal, and you can also see the motor on status in this mobile application. And side by side this relay will turn on, and also this motor start pumping, so you can see water also start moving from this side. So we can demonstrate that part. So now I will show the complete project setup. So this is the complete project setup. Now I will remove the moisture sensor from the water. So you can see I remove the moisture sensor from water, and you can see that as soon as I have removed the moisture sensor from water, the motor start pumping, and it is giving the water to the plant indirectly. It is demonstration, so it is, you can assume it is start pumping water. So this is the one part. So this is the one part of our project. Now the second part is that whenever I place the moisture sensor inside this water again, this motor should stop. So I will again place the moisture sensor. So I have put the moisture sensor into the water again. Now we can observe the motor status on the mobile application also, and the motor should be stopped. Now you can see the motor is stopped, and you can see also on the mobile application the status of motor is red, that means motor is stopped. Now we can see the another part of this project is like that whenever we start the motor, that like if we remove the moisture sensor from the water, then motor will be stopped, and after that if the rain sensor detect the water, then motor should be stopped. So that part we will see again. So for that I again remove the moisture sensor from the this water. Now you can see the motor start pumping the water. Now I should put some water on this rain sensor so that it detect the rain. So you can see I have placed a 2 to 3 drop of water into on the rain sensor so that it should detect the rain. Now we wait for some second. Now you can see the moisture sensor also out of the water, and the motor is stopped because we have provided the rain on this rain sensor, so that you can see the moisture, some droplet of water is present on the rain sensor, so that it will detect the rain is detected, and the motor stop pumping the water. You can also observe that this moisture sensor is out of water, and even this pump is not start on. So that is the second part of this project. So I hope you understand the project. Also you can see on the mobile application the status is off. So before start the hardware connection part, I request you please subscribe my channel. You can see currently I have 1231 subscribers, is more than 1000, but to verify my channel on the YouTube I require 4000 watch hour, and currently I have approximate 3000 watch hour. So please watch my each and every video from my playlist. Just go to my playlist. This is my playlist, and go to my playlist. You can see there are many videos on Raspberry Pi Arduino webinar, and in Raspberry Pi more than 45 videos there. And if you want to learn the Raspberry Pi from me in the free, you can subscribe my channel. You can take this advantage, and all these video are very unique. You will not find this video on the YouTube channel. So please subscribe my channel. Please watch my complete video. Thank you for. So whenever you plan to start the hardware part, make sure you have Raspberry Pi 3B or 4. You can use any Raspberry Pi. In my project I have Raspberry Pi 3. So whenever you buy Raspberry Pi 4, Raspberry Pi 4 or Raspberry Pi 3, you can see this pin is open and you can not able to find out the pin number of this Raspberry Pi. So I will provide you basic idea behind this pin number. So first pin, that is the you can see this is the LED, and LED side first pin it is nothing but the 1 number pin, then second pin is this one, then third, and then fourth. So odd number pin should be connected at this row, this column, and even number pin at connected this column. So it is very difficult at the runtime. You can find out the number, so it is very easy. You can take the one paper and you can draw this pin name as it is, like I have did 1 2 3 4 5 6 7 8, and plug this pin on this Raspberry Pi so that you can easily find out the pin number of Raspberry Pi. So now you can see I have placed my paper on the Raspberry Pi pin, so you can see easily I can identify the pin number of Raspberry Pi, and during hardware connection I can easily find out which pin is connected at which point. Okay, now first we will connect the LCD module with Raspberry Pi. As you can see at here I have LCD module separately and Raspberry Pi separately. So on LCD module you can see this is designed by me, and also the you can see it is completely designed on, now you can see it is completely designed on the 0 PCB. So how I designed this, you can see on the screen the schematic diagram of this LCD module. So on real time we have this only we get this. So on real time when you buy on the Amazon, you only get this LCD module, and this LCD module has this 16 number or 50 number pins. So with this 16 and 50 number pin, you have to how to connect that one with Raspberry Pi. For that you require this 0 PCB module. So how I design this 0 PCB module, by using the circuit diagram. So I will share the circuit diagram on screen. You can see on the screen whatever the pin, output pin is connected to input side of controller. So that input side of controller pin is nothing but our floating pin, and with that floating pin we will connect our LCD module with any other controller. So with the help of this circuit I have designed this circuit. So when I plug this, so whenever I design this circuit, I need to plug this one LCD module on this one. Okay, now with this you can see at this side we have common VCC, at this side we have common ground. Then at this point you can see there is a input pin of this LCD module. So first pin is RS pin, then enable, then D7, D6, D5 and D4. So these are the output pins of this LCD. So we will connect only this pin with Raspberry Pi, the VCC and ground pin also with Raspberry Pi. So I hope with the 0 PCB or breadboard PCB you can able to create this circuit with the help of circuit diagram I have shown on the I already shown on the screen. So please create this circuit diagram by your own, by soldering the PCB like this one, or by using the by using the breadboard also. Okay, now once you get this circuit, once you create this circuit on the 0 PCB, now we will connect this pin one by one with Raspberry Pi. So first point we will connect the RS pin to pin number 7. So for that we require the female to female connector. So I will connect the RS pin to the pin number 7. You can focus, this first pin is RS pin. Then I have connect this RS pin to pin number 7 of Raspberry Pi. So before starting the next part, I need to pay your attention here. You can see on Raspberry Pi, I by myself only created this page and paste this page on the Raspberry Pi pin, so that I can easily identify the pin number of Raspberry Pi. So even number pin come at this side and odd number pin come at this side, but with this page number I can easily identify the pin number of Raspberry Pi. So I hope you also do the same at your side, so that you can easily identify the pin number with Raspberry Pi. So first pin is this one, then second, then third, then 4, 5, 6. So even number at this side and even number at this side and odd number at that side only. Okay, once you connect the RS pin, next pin is enable pin. So I will connect enable pin to pin number 11 of Raspberry Pi. So take this enable pin and I will connect this enable pin to pin number 11. Now we will connect the D4 pin from this PCB to Raspberry Pi 12 number pin. So connect D4 pin with Raspberry Pi 12 number pin. Okay, after that connect the D5 pin to Raspberry Pi 30 number pin. So D5 pin from Raspberry Pi connected to 13 number pin. After that D4, D5, D6 pin should be connected to Raspberry Pi 50 number pin. So D6 of LCD should be connected to Raspberry Pi 15 number. Then after that D7 pin should be connected to Raspberry Pi 16 number pin. So D7 should be connected to Raspberry Pi 16 number. So in this way we have completed the connection of LCD module. With Raspberry Pi. Now we will give the common ground and common VCC to Raspberry Pi. So this side act as a common ground and this side act as a common VCC. So ground pin of Raspberry Pi is nothing but the 6 number pin. So I will connect ground pin to Raspberry Pi 6 number pin. Then VCC pin of this LCD should be connected to 2 number pin of Raspberry Pi. So VCC pin of this LCD should be connected to 2 number pin of Raspberry Pi. So in this way we have completed the circuit part of LCD with Raspberry Pi. Now the next hardware is after connection of LCD is this one. So basically this is a 0 PCB and this 0 PC I have these 2 buck strip, and opposite side you can see I have soldered all the buck strip at this side and second buck strip solder completely. So basically it is act as a common VCC this point and common ground this point. So whatever the Raspberry Pi VCC pin come here and common ground pin come here. So whatever the sensor pin require VCC and ground pin we have given from here, because we have to consider one common VCC and common output point centrally. So that I have connected this circuit. So you can also design this circuit by using the PC board. If you have, then you don't require this breadboard. If you have breadboard, then don't require this 0 PCB and the buck strip. But if you have the 0 PCB and buck strip, you can prepare this circuit by yourself only. It is very easy. So the first part is we have to take common VCC pin to this side first. So Raspberry Pi second number pin act as a VCC pin, that is 5 volt pin. So I will connect a 2 number pin of Raspberry Pi to 1 pin of this buck strip. So for that I have take one male to female connector and connected that pin to here. So basically this row will act as a complete row, act as a VCC pin right now. I have taken the common ground pin. So Raspberry Pi 6 number pin act as a ground pin. So I will connect the 6 number pin to this pin buck strip. So now we can have the common VCC pin and common ground pin. Now the LCD pin that we have connected already, we have taken we should connect the common that is ground pin of LCD. This one is ground pin of LCD, should be connected to common ground pin. So this is the ground pin of LCD and I connected this ground pin to common ground pin here. Now the common VCC pin of LCD should be connected to VCC pin of Raspberry Pi, common VCC pin. So VCC pin of LCD I have connected here. So in this way complete LCD circuit is completed. Now the next sensor we have to connect this one, moisture sensor. You can see whenever you order the moisture, so whenever you order the moisture sensor from the Amazon or from the Flipkart, you will get separated these two circuits. So you will get separated these two circuits. So whatever you have to do, just plug two wires here and plug any two wires here. You can see there is no polarity actually, so you can plug any pin at this side. So these two pin I have plugged here. Now at the output side of moisture sensor, this is a driver for moisture sensor, and you can see this one is potentiometer, and through this potentiometer you can adjust the sensitivity of the moisture sensor. And another 4 pin we have with moisture sensor is VCC, ground, analog output and digital output. You can see on the moisture sensor there is a printing of that number. So basically what we do, we will connect VCC pin of moisture sensor to common VCC pin of our Raspberry Pi. Then ground pin of moisture sensor again connect to common ground pin of our Raspberry Pi. Now the next part is we use digital pin. We do not use the analog pin because digital pin is enough to detect the water is not, and to adjust sensitivity you can adjust by using this potentiometer, so how much level of water you want to detect. So first we connect the VCC pin to the common VCC pin again. So I will put my moisture sensor here, and the first part is VCC pin. So I will take one male to female connector and connect common VCC pin, that is VCC pin of moisture sensor to common VCC pin of Raspberry Pi here. Now the next part is we have to connect the ground pin of moisture sensor to ground pin of our common ground pin. So moisture sensor common ground pin, this one is ground pin of moisture sensor, and I have connected this ground pin to common ground pin. Now the next part is digital output pin of moisture sensor. Moisture sensor should be connected to Raspberry Pi directly. Now the next part is we have to connect the digital output pin of moisture sensor to Raspberry Pi 31 number pin, and same pin we have defined in the code also. So connect the output pin, digital output pin of moisture sensor, that is D out from the moisture sensor to Raspberry Pi 31 number pin. Okay, now the next part is rain sensor pin. So basically whenever it is same, whenever you order the rain sensor from the Amazon, again you will get these two circuit, and you have to connect these two pin at this side. So after that the main point is in the rain sensor is that, like the same in moisture sensor, you should have one potentiometer to adjust the sensitivity of the rain sensor. Then again at the output side you can say there are the 4 pins. One is VCC, ground, analog output and digital output. So one by one we connect all the pin to Raspberry Pi. So first pin we should connect the VCC pin of a rain sensor to Raspberry Pi common VCC pin. So this is the VCC pin of rain sensor and should be connected to common VCC pin of Raspberry Pi. Now the next part is ground pin of rain sensor should be connected to ground pin of Raspberry Pi. So again I will take one male to female and connect the ground pin here. Now the last pin, that is the rain sensor pin, output pin should be connected to Raspberry Pi 33 number. So D out pin of a rain sensor. So this is the rain sensor D out pin should be connected to 33 number of Raspberry Pi. So this is my 33 number of Raspberry Pi. So you can see Raspberry Pi basically odd number pin should be connected all this side, and even number pin should be connected to at this side. Now the next part is we have to connect the DST11 sensor to Raspberry Pi, and it is very easy. So you can see on the DST11 sensor, whenever you buy the DST sensor, it has the 3 pin. One is VCC pin, then again the common data pin, and the third one is ground pin. So it is your same as VCC pin connected to VCC, ground again ground, and data should be Raspberry Pi. So first one is common VCC pin. So this one is connected, this is the VCC pin, and should be connected to common VCC pin again. Then ground pin should be connected to common ground pin. And the last part is data pin of DHT11 sensor should be connected to GPIO 18 number of Raspberry Pi. So properly connect this pin to Raspberry Pi 18 number. So in this way we have completed the rain sensor, moisture sensor, DHT11, then LCD. Now next part is remaining the relay circuit. Relay circuit. So basically relay again have the same pin. So first pin is VCC pin, next pin is ground pin, and one is input pin. So basically this is my 4 relay board, so that I have the 4 input pins at this side. So if you want to buy a single relay board, then you have only one input pin at this side. And yeah, so basic part is you have to connect first VCC pin to common VCC again. So first I take the VCC pin of relay board to common VCC pin. Then after that the ground pin should be connected to ground pin again. This is the ground pin of relay, and it should be connected to common ground pin again here. Now the last part is only IN1 pin, that is input pin of relay, should be connected to. So input pin of relay should be connected to 29 number pin. So connect the IN1 pin of relay to 29 number pin of Raspberry Pi. Okay, so in this way relay also completed. Now the next part is motor. At the output we have water pump motor. You can order this motor from the Amazon. It is 70 or 80 rupees motor. So this motor again have the 2 pin. You can see one black and one white. So black is nothing but the, so this 2 motor having 2 pin again, one black and one white. So black pin is nothing but the ground pin and white pin is nothing but the VCC pin. So you can see basically relay has the 3 pin at the output side. This one, this one, and this one. Each relay having the 3 pin. So middle pin is nothing but the common pin for this 2 point. So whenever the relay is connected, this middle one pin get connected with this pin. So what we do, so we will take this common pin to the Raspberry Pi ground pin, common ground pin, and this one pin should be connected to motor ground pin. So first connect the common ground pin to this relay pin, middle one pin. So now I am connecting the middle one pin of relay board. To the ground pin of Raspberry Pi, so common ground pin here. So I have connected middle one pin to ground pin. Now the next part is this ground pin of this black one is ground pin of this motor, should be connected to left side of relay board, that is nothing but the common open pin. So I will connect this pin to the common open pin again. Should be connected to common open pin, that is the left side pin of Raspberry Pi. So place that pin here and connect here. Okay, now what you have to do, the power pin, that is the red pin of this motor, should be connected to Raspberry Pi VCC pin again. So I will take one VCC pin here and I will manually connect this pin to this one. So in this way my motor connection is completed. So in this way you can see my motor connection also completed and the circuit connection also completed. Now the very important point is this motor will consume the lot of current when we give the power to this motor. So make sure you should have the 5 volt and 2 ampere power supply to Raspberry Pi. You should give the 5 volt 2 ampere current power supply. So you can see this is my mobile charger and having the 5 volt 2 ampere current rating. So because of this it will provide sufficient current to all the circuit and your project will work successfully. So please follow each and every step for the hardware connection, and definitely you can able to design and develop your project by your own. So we will see what are the importance library that need to be installed into your Raspberry Pi so that you can access the PAHO client. So first library is sudo pipe install PAHO Mqtt. So to install this PAHO PAHO client library on your Raspberry Pi, go to the terminal and just type this command on your terminal. Press enter. So it will install the PAHO client on your Raspberry Pi. Make sure internet is connected to your Raspberry Pi before installing this. Okay, now we will understand the importance of each and every line from the code. So first line is import time. So basically if you want to create some delay in your code, you require the time library. The next library is import OS. If there is any OS functionality in your project, then you require this OS library. The next library is import Raspberry Pi.gpio as GPIO. So basically if you want to work on any Raspberry Pi GPIO pins, you require the permission, or you can say if you want to access that GPIO port, then you require this GPIO library. Then add port DSTS. Basically if you want to use the DSTS sensor like humidity sensor and temperature sensor in your code, then you require this library. Next three lines are basically used for the Mqtt protocol. So if you want to send some data from Raspberry Pi to a mobile application, then require Mqtt protocol, URL protocol. Then for the protocol you require this three library. Next line is import set mode GPIO board. So basically if you want to like Raspberry Pi can divide into two parts, Raspberry Pi as a complete board or Raspberry Pi BCM chip. So in our project we will use two methods. One method Raspberry Pi complete board, that is GPIO.board, as for the LCD relay, then rain sensor, then moisture sensor. And for the BCM chip we will use Raspberry Pi BCM chip we will use for the DHT11 sensor. So to declare that as a Raspberry Pi complete board, we require this line. The next line is GPIO.set warning to the false. So basically whenever you run the code, Raspberry Pi gives you warning that whatever the line you have used, that GPIO pin you have used in your code is already used before. So to avoid that warning, you should use GPIO.set warning to the false. Now next line is sensor DHT11. So basically if you want to use DHT11 sensor, you require to access that package of that sensor, and to access that package you require one variable. So to create that variable, this line is very important. Now next line is RS pin to the 7, enable pin to 11. So basically in the hardware part we have seen that the RS pin is connected to 7 number pin, then enable pin is connected to 11 number pin. So whatever the LCD pin we have used in hardware part, that I have declared here. Same for the DHT11, whatever the like DHT11 is a little bit different. So you can see DHT11 is 24 number pin. So actually on hardware part, now the next line is DHT11 sensor is connected to 24 number, and you can see in hash define I have write here GPIO 18 number in a board. So what is that mean? So basically if you want to see the pin, you can go to the Raspberry Pi terminal, then GPIO.read all, and whenever you type the GPIO.read all functionality, you can find the BCM number, and inside this BCM number, because DHT11 pin work with the BCM chip as a complete BCM board. So I have selected BCM1 and BCM24 number pin, and you can see BCM24 number pin is correspond to Raspberry Pi board 18 number pin. So whenever in hardware connection, so that we have connected the DHT11 output pin to 18 number, but on the programming we have declared as a 24 number. So that's the reason behind this. Other pin as work with the same that we have connected during the hardware, that is means LCD 7, and also we define the LCD RS pin here 7 also. The same for the we have connected 11 number to enable pin. Same 11 we have defined here. Only the difference for the DHT11 sensor. So I hope we understand the what is difference between this pin number and DHT11. Now next pin is relay 29. It is same as the LCD pin. So relay 29 is nothing but this physical pin and 29 number. So this pin we have connected on actual hardware also. And then last pin is soil moisture pin, that is connected to 31 number of Raspberry Pi. Then rain sensor also connected to 33 number of Raspberry Pi. So this is all about the pin connection of our project. Now next there are some delay. We will use this delay variable in later our code. The next part is whatever the GPIO pin you have declared, whatever the relay pin you have declared, that pin you have to consider as a output or input. So LCD pin, then relay pin, all are output pin, because Raspberry Pi send the signal on that LCD pin, Raspberry Pi send the signal on the relay pin. So so that we have declared GPIO.setup, pin name, then GPIO.out. So whatever the output pin we have declared here. Now whatever the input pin we have to declare again. So soil sensor is a input pin to Raspberry Pi, rain sensor is an input pin to Raspberry Pi. So we declare it GPIO.setup, soil sensor pin to GPIO.in, and same GPIO.setup, same rain sensor pin GPIO.in. So whatever the input pin, whatever the output pin we have declared in this line. Now the next line is def on connect, then def on publish, then subscribe. All these are function basically used whenever we use the MQTT protocol in our code. So def on connect function basically used whenever your Raspberry Pi gets connected to the MQTT server, then this function automatically call, and it is printing on the this window here connected with MQTT server. So once your Raspberry Pi gets connected with MQTT server, this message will be printed. Now on publish is basically, so whenever you want to send some data, Raspberry Pi wants to send some data on the mobile application, then this on publish function will be used. Then we pass whatever the real-time value of sensor through this function, and this value will be published on the MQTT server. Then on subscribe is basically function whenever you access, if Raspberry Pi want to access data from the mobile application, then this time this function will be used. Now if you want to access all these function on connect, on publish, on subscribe, then you have to create some variable, object variable of MQTT protocol, and from that variable you can access that data. So to create that object variable, you have to consider this line power.client, then MQTT. So through MQTT variable we can access the different functionality of the MQTT protocol. So again there are some callbacks. Now we have defined here the whatever the function, then for that function we have to define the callbacks through this line. Then next part is your broker, and it is very important in mobile application designing. You also observe that we already provide this broker address in mobile application. So if you want to change a broker in future, let's say another broker, you have to just this you have to change this highlighted line only. TCP only remain as it is, / also remain as it is, only broker name will be changed. So whatever the broker you want to use in your code, you can change with this. Then os.environment get, so basically it will create one URL string with complete this ID, then this store into URL string variable. Then URL parse will create again URL for to connect with MQTT server. Then MQTT.connect functionality basically used to connect your user host name, that is this one, and your port name, that is this one, with your MQTT server. So basically MQTT.connect function, once this function get executed, and once your server Raspberry Pi gets connect with your server, then automatically this function will be called. So this is the basic idea behind this MQTT protocol. Now till from line number this one LCD width, from line number 72 till LCD function, LCD byte, then LCD toggle, then LCD string. It's already I have till line number welcome, this one 167 is already explained in my protest simulation video of this same project. So if you want to learn this, basic functionality of LCD, you can watch my protest simulation of LCD with LM35 video, and in that video already explained this functionality basic, because if I explain here then it will take long time. I will provide the link in the description of that LM35 with LCD, and from this video you can easily understand what is the importance of each and every line of this function. LCD byte, then LCD toggle enable, and then LCD string. So please watch that video if you want to understand that code. And if you next line is 168, that is LCD string smart irrigation. So basically whatever the project name of this project we are printing on the LCD, that is LCD string by using the LCD string function. So LCD string, then we are passing the whatever the command we want to print, whatever the variable, whatever the string we want to print on the actual LCD, we have to pass here. Then LCD line number 1, that is on row 1 of LCD. Then project will be printed on row 2 of LCD. Then some delay, then GPIO.high for relay. So at the starting we have to turn off the relay. My relay work as a active low logic, that means whenever I give the 0 signal to the relay, it will turn on. In your case, if you have the different relay, you can work as active high logic. So in that case, in your case, so if you work as active high logic, then you can pass here low. So GPIO.output, so whenever we have to pass the high signal or the low signal on any GPIO pin, you have to use this line GPIO.output, then pin name, then GPIO.high or GPIO.low. So if in this case I have to pass relay pin to the high. Then motor status is 1. I will tell importance of this line later. Then while 1. So while 1, whatever the code inside of that while 1, it will execute for infinite number of time. Then MQ.loop, whenever you want to connect your Raspberry Pi to infinite number times with your MQT server, then you require this line. Then next line is moisture output is equal to GPIO.input. So basically here we are taking the whatever the soil moisture output, whenever it detect the water level, then it will give the signal to the moisture output variable, and we are comparing that signal later. So if you want to take Raspberry Pi want to take any data from any pin GPIO pin, then this function will be used GPIO.input, then pin name. Same that for the range sensor, if you Raspberry Pi want to take the input from the range sensor, then GPIO.input pin name, then one variable, that value will be stored. We will use import this variable later. Then print whatever the range sensor output, that is print on this screen. So that I have printed here range sensor, then plus is a string and string strop. Then what is the mean by this strop? So basically range sensor output is coming in the terms of 0 and 1, which is integer form. But if you want to print any value on the LCD or print any value on this window, then you require the string variable. So to convert integer into string, then you require strop, then variable name. So indirectly I am converting integer value into string, and plus is nothing but the concatenation of two strings. So first string is rain output, plus second string is whatever the output, actual output. So it will show that output here. So next line is if you want to read the humidity value or the temperature value from the DHT sensor, then this line will be used. You can see this line. Then next is if humidity is not none and temperature is not none. So basically it is checking continuously so basically at this line it is continuously checking the humidity sensor is connected or not properly. So if this value is none, that means the humidity or temperature sensor is not connected properly. So in that case we have to go to the else part, and in the else part we have to print failed to detect DHT sensor on the LCD. So you can easily identify the DHT sensor connected or not, and this message will be printed on the LCD. And let's say if the humidity sensor is connected and it's working properly, then we have to print the temperature value on the humidity value on the LCD. So how to print? Same function LCD.string, LCD string, then temperature is equal to plus is concatenation of the second variable, then string integer string of temperature, because it is the integer value and you have to convert that integer value into string, so that string of temperature. And on line number 1, same for the line number 2, you have to print from the line number 2 you have to print the humidity value. So again the humidity is equal to plus string humidity line number 2. So in this way we are printing the humidity and the temperature value on the LCD. Then after that MQT.publish. So whenever you want to print data or you want to send the data on the mobile application from the Raspberry Pi, then we have to require this function MQT.publish. Then the HUM is nothing but my token. So you can replace your token here with your name, with whatever your token you want. So hum is used for the humidity in my case. So hum also I will declare in my mobile application as a token to detect the humidity value. Same for the MQT.publish, TAM is a token, and with that token I am printing the whatever the real time temperature value on the mobile application. So you can replace the sum or temp with respect to your variable, and you also replace that name on the mobile application. So with this line we are sending the humidity and temperature value on the mobile application continuously. Okay, now next part. If the rain sensor is 1, so that means rain is not detected, and rain sensor is 0, that means rain is detected. So once the rain sensor is 0, let's say this else part will be executed, this else part, and in the else part we have to turn off the relay, because we have to turn off the motor. So to turn off the motor I have to send the high signal on the relay pin, and we have to send the MOT 0. So it is nothing but the MOT is token, and with the token I am sending 0. Once the 0 value received to the mobile application, then it will change the color to the red color. So for that I am using this line. Then I have to print value rain detected on the LCD and motor stop on the line number 2 of LCD with this line. So in this way we have checked the rain is detected, and what happened when rain is detected, that code is this one. Now if rain output is not equal to 1, so what is this mean? So this means that rain is not detected, and in this case rain is not detected. So what will happen? Then we have to check the temperature and humidity value. So let's say if the temperature is greater than 30 and the humidity value is less than 27, or means either these two condition or single this condition. So or moisture output is equal to 1. So whenever the water is not detected, that is the water level is not detected by the moisture sensor, then in that case moisture output is equal to 1. So in that case we have to turn on the motor, because there is no water. So to turn on the motor, for the moisture output is equal to 1, and LCD is equal, then we have to print motor on the LCD, and mot is equal to 1 we have to publish on the mobile application. So once the mobile application receive the 1, then it will change the color to the green, and motor will be start rotating, because we have to turn on the relay. So to turn on the relay we have to use GPIO.output relay pin GPIO.low signal. So in this case we will turn on the relay. So this is the one part, because we are detecting the moisture sensor. So let's say if the moisture sensor output is 0, so in that case the moisture sensor detect the water, and we have to turn off the motor, and we have to pin motor off on the mobile application. So for that reason this code will be responsible, and it is same code when the rain sensor detected only the part is motor off present on the LCD, motor 0, and the GPIO.high signal I am sending by using this line. Now the next part is what is the importance of temperature is greater than 30 and humidity less than 27. So let's say there is a sufficient level of water inside for your plant, but atmosphere condition is not okay. So in that case the temperature is greater than 30 and humidity is less than 27. So once this value also reach, even if there is water, then to maintain that atmosphere condition, again the relay will turn on, that motor will turn on, and it will give water to the plant for that case also. So for that reason it is this line. So if you want to change the value of temperature, if you want to change the value of humidity, you can change with this line. So yeah, this is the idea behind this complete code. I hope you understand. If you don't understand, please watch it again, and I will sure if you will definitely understand each and every line of code. So now first we see how to create the mobile application to send the data from Raspberry Pi on the mobile. So first you need to go to the Play Store. So type Play Store. Then after you type Play Store, go to the search MQTT dashboard application. So once you search MQTT dashboard application, you can see this MQTT IOT and Node-RED controller dashboard application you should open. Then after that you should install that application. So once you install that application, open that application. So once you open that application, you can see this window will open, and first we need to add the broker for our project. So if you want to add the broker, just click on the add first broker. Then after that you should give the broker name here. So in that case my broker name is let's say Rahul. Then you should give the broker address. So broker address is starting with TCP double dot and the slash. So in code you can see we already given the broker address on the line URL string OS environment get then TCP broker EMQX IO. So type as it is that line here. So first type TCP, then double dot, then /2 times, then broker, then .emqx, then .io. So this is your broker name. After that you have to provide the port name. The port number is 1883. That also we have given in our code. After that click on save button. So once you click on save button, this broker will be start connecting, and once they start connecting, it will show broker is connected and there is nothing. Okay, once you configure the basic MQTT dashboard application, then you will see the blank screen on your side. You can see at my side there are 3 buttons already configured for this project. So we will see how to configure these 3 buttons. So first part is, if you want to give the smart irrigation system name, so just click on this line, then go to the manage broker and click on this button. Then you can type your name, project name here, and click on OK. So once after that, smart irrigation system project also name present on your side. Then first part is humidity, how to create this button or create this application. So click on this plus button. So once you click on this plus button, go to the text. So once you go to the text, give your name, humidity, status, or whatever you want. Then in the programming, we have defined the topic is hum for humidity. So HUM is a topic, and unselect this enable publishing because we are not publishing any topic. Then after that, go to here, paint the background, also selected. Then go to the question mark, and here you can select any color and select any whatever the logo you want for this. So I select this one and click on OK. Then after that, you can see humidity with logo and hum is a topic, and click on OK. So you can see humidity status, it is a new value, new button will be present, and once you run the code, you will observe the value here. Now the next temperature, for the how to create the temperature status, again click on this plus button, then again go to the text, and once you go to the text, give here name temperature. Then after that, go to the question mark, select any color, then select any logo that you want, and just click on OK. Then go to the paint the background, disable the enable publishing, and topic is tem, and click on OK. So this is a topic. I will check the topic first with my existing button. So I will double click on this one and just confirm the topic. So T is capital, so tem. So you can see, go to this edit, and T is capital here, that is tem, and this is a topic. So whatever the topic you are defining in the program, give topic as it is here. Now the next is motor status. So how to give this motor status, again go to the plus button. First we check the topic, what is topic for that. So go to edit, first I check the topic, so MOT is topic. Okay, so to check the motor, to create the motor status, just click on this plus button. Then once you click on this plus button, just go to here toggle. So once you go to toggle, disable publishing, then give your name, motor status, or whatever you want. Then after that, go to question mark and select any color, select any value, any logo that you want. Let's say I am selecting the fan, this one. Okay, and then here is topic, MOT, it is topic. And for this on value, that is when you send the one value, what should be the color. So color is green for on value, and the fan should be on. So this is the logo whenever I get the one value. So here I type the 1, and second is 0, so it is off. So again go to the question mark, red value, and again type here fan, and off fan. Okay, so you can see 1 value for green color, 0 value for red color. Topic motor status is value, topic is MOT, and click on OK. So you can see also go to the edit and paint as background, and click on OK. So you can see motor status also present. Just check, we check the MOT, yes, it is correct name, MOT, and here also MOT. Yeah, so these three you can see these 3 topic just we have created, and it is already present. So in this way you can create your own value, own button with own color, and the topic should be matched with the code. Now we will see how to run the project. So it is very important. First step is to check your internet is connected with your Raspberry Pi. Next is very important. You have to install all the library that I already explained, and the hardware should be properly connected as per my guidance. Now next part is then you have to download this program from my Google Drive link. The program name is Smart Irrigation System.py. So download this program from my Google Drive link given in the description of this video. So then double click on this program. So once you double click on this program, click on this run button. It will take some time to load the library. Then you can see connected with MQT server. That means your program is started and rain output is 1. That means your project is started. Also you can see different mid 1, mid 2. That means your values start sending on the mobile application. And if your hardware is connected properly, you also see the message on the LCD. So in this way you can run your project successfully.